So how many of you are excited about Cassandra 4.0? I know there are only 17 people right now here, but are you excited about 4.0 coming out and working on using 4.0 or working on it? Cool. I'm excited about it too. There are so many interesting things that are coming out of 4.0 that it's not enough to have one or two sessions talking about what is new in 4.0. Yes, yes. Not having the IP to be the sole identifier itself is enough for me to upgrade to 4.0. I'd like this session to be interactive. So generally, people in Cassandra sessions are very knowledgeable about Cassandra. So if you have something that you can add, please feel free to add to the chat. I don't know everything about all the stuff that I'm talking about today, but I'm trying to, I tried to look through all the list of changes that went into 4.0, and I really had to struggle to reduce the list of stuff that I could put on slides and cover in 40 minutes. Cool. So it's 9:50. We can get started. If my audio or video drops out, please ping on the chat, and I'll join back. I had some internet trouble yesterday. So, okay, so let's get started. I'm Dinesh Joshi. You must have heard me speak at some of the Cassandra conferences or database conferences. I am a senior software engineer at Apple and also Apache Cassandra committer. I've been working mainly on 4.0. I have worked with Cassandra for many years, but only about 2 to 3 years ago, I started contributing back to the code base. And 4.0 is the first major release that I've been participating in since I started working on Cassandra's internals. So today I'll be talking about some of the interesting features or hidden features in Cassandra 4.0. They may not fit strictly the definition of a feature. There are some interesting bug fixes also that I'm calling out here, and some behavioral changes that some people may appreciate those changes, some people may find it annoying, but at least you are forewarned that those features or bug fixes may affect you when you run 4.0 in your data centers. So so we'll be looking at what's new in 4.0. These are features that you're likely very familiar with to begin with. Then we will look at some of the hidden features in 4.0. And these are a little bit understated features. They are not features that that people don't know about, but these are features that mostly get overlooked because there is one-line description about those features. And then I'll summarize the talk. So let's get started. So 4.0 key features are audit logging. This allows us to perform audit logging at the database layer. A lot of you might have heard about it and are excited about it because this allows us to do SOX compliance and other compliance related work a lot better with 4.0. Earlier, before Cassandra 4.0, you had to implement this in your application layer, and what it was the application would need to log every time there is some access. Now that it's implemented in the database, you don't have to implement audit logging in your in your application. You can turn on audit logging on the database. So this is a feature that most people are familiar with. Z standard compression is an interesting feature. If you look through the features and the tickets in 4.0, you will notice that a lot of these features are are nice to have, but Z standard compression actually if you look at all the tickets related to it, you'll see that there is a significant impact in compression. So disk saving is pretty high with the standard. There's faster streaming. So zero copy streaming or faster streaming is something that I think a lot of us are excited about. The internal messaging between nodes within the cluster, so internode messaging has been rewritten to be asynchronous using NetD. Earlier, we were using Java sockets and a thread pool. So what async IO brings to the table is a lot of, you are going to see that the number of threads that we run within the Cassandra process reduces. And this maybe not, it may not be something that affects small clusters as much as it affects larger clusters, because with smaller clusters, you'll spawn maybe 10 or 20 threads. It's not a big deal, but for larger clusters in the hundreds of nodes, you'll spawn one thread per connection type per connection type per node, and that will mean you'll spawn something like 300 to 600 threads, depending on the kind of workload that is happening on Cassandra. So this is a big improvement over 3.0 and 3.11. And then virtual tables for operators. Virtual tables give an alternative to JMX, and Cassandra as a project is moving away from JMX for various reasons. If you don't know what those reasons are, I would be happy to chat with you. But JMX is not the preferred way of getting data out of Cassandra, like metrics or performing operations. JMX has its host of issues. 4.0 also brings in, but it is an experimental feature. It is a very invasive feature as well. So it's a feature that allows you to make a few replicas in cluster as witness replicas, and essentially doesn't allow it reduces your storage footprint without reducing your durability guarantees. And then there's SSL hot reloading that is available in 4.0, and this is a pretty cool feature. So if you're doing any form of certificate rotation on a regular basis and on a frequent basis, you don't want to keep bouncing Cassandra all the time. You just update the certificates on disk, and Cassandra automatically reloads those certificates when it detects that they have changed. So that way, if you're deploying Cassandra in a secure environment, you don't need to keep on bouncing Cassandra. So from a SRE ops perspective, this is a really good feature. I think there's a question from Fred. We'll still be able to access all those fields in a JVM agent though, right? Yes. So with 4.0, yes, you will be able to still, we are not removing anything from JMX. We are adding stuff to virtual tables. So you can still expect the same behavior as with previous releases of Cassandra. You won't be, we won't be removing those fields. Maybe they get deprecated with Cassandra 5.0, but that's a different discussion. And then finally, you have SQL, which is full query logging. Audit logging and full query logging are based on the same library or underlying infrastructure framework that Cassandra uses, which is Chronicle Q. It allows you to actually record queries at very high throughput. So without really affecting the performance of your client application, you can actually record all your queries on a given Cassandra node. And this allows us to do some interesting stuff like, capture the queries and replay them on a test cluster. So for those of you who attended my session yesterday, FQL is one of those tools that we use for replay testing in Cassandra. So let's dive into some of the lesser known features. These are features that everybody knows, and some of these are bug fixes. So let's see. Cassandra 13241. The reason I have Cassandra tickets in here, Jira tickets, is because there's a lot more information and discussion and context around what this is in the ticket. So if you are motivated to look at what went in reducing this ticket or change, please feel free to look at the discussion on the ticket. So default chunk length in KB compressed is going to change from 64 kilobytes to 16 kilobytes. Um, for those who are not familiar with this setting, this basically controls the compression chunk in Cassandra. And why is this relevant? It's relevant because for 80 to 90% of Cassandra users, they store small values in Cassandra. And so if you have a 64 kilobyte chunk length, you are experiencing a very high read or write overhead. What that means is that, let's say you're storing a value which is 100 bytes, you are reading and writing the chunks at 64 kilobyte length. And that's a pretty large overhead. So one of the first things that most developers or ops folks or SREs do is when they deploy Cassandra is they actually bump this down. For 90% of our use cases, you will see that this is something that has to be around 4 kilobytes or definitely less than 64 kilobytes. So this is one of those notable changes, and defaults changing in any technology is a big deal. So just make a note of it. The other change that's coming in is configurable support per node. This is, I think, by far an interesting feature for those who want to deploy Cassandra and save on those addresses, right? So a lot of us actually deploy Cassandra, and earlier Cassandra required you to have a unique IP address for node instance. And that's not a big deal in most cases, but some of the use cases actually call out for using certain types of IP addresses, which may cost you money. So what that essentially means is that even though Cassandra as a process doesn't really benefit big time from using individual IP addresses, you still are paying for 4 times or 6 times that you should actually need to pay for. So now you can configure the storage port per node so that Cassandra uses the same IP address across different instances, but runs on a different storage port. So that's another notable feature in 4.0 that most people may have missed. Cassandra 12.681. And this is kind of a silly thing, but it's an important thing. Cassandra will no longer allow invalid key space replication options, such as invalid data center names for network topology strategy. This is a very self-explanatory feature, but you wouldn't believe the number of times somebody would mistype a data center name, and Cassandra would happily accept it. With 4.0, finally, it's kind of getting fixed so that you don't need to worry about somebody typing in a wrong data center name. There are other replication options also that get validated, but this is one of those notable things. Really don't need to be calling this out as a feature, but I thought this is an interesting change. Most operators will be super happy with this change. All right. 10.404. So no mode encryption transitional mode. Now, what is this? This is a very cryptic way of saying that 4.0 allows a single port to be used for both secure and insecure connections between Cassandra nodes. So, so here's the thing. In Cassandra pre 4.0, we had a setting called as SSL storage port. And this setting basically meant that if you want to run Cassandra in a mode where you have connections going to a secure port, then you had to actually specify a different port. And this is internode connections. It's not the client connectivity, it's the internode connectivity. And this is pretty annoying from a operator standpoint, is because when you want to switch non-SSL to SSL for internode communication, you now you're kind of in this weird state where you have to use two different ports. And for some folks, opening up a port is an easy job. But for some other folks where there are uh, firewalls that prevent access to arbitrary ports, you would end up having to open a ACL, which is an access control list, between all IP addresses for that particular port. So it was a lot of hassle. So what 4.0 did with the rewrite of the internode communication using NETI and async IO, we allowed the same port to be reused for secure and insecure connections. So if you want to terminate TLS, you can do it with the same port. So with that, we have deprecated SSL storage port, and now storage port is simply the port that you use. And you can simply specify whether you want optional TLS or you want TLS to be required. And the storage port, when Cassandra detects an incoming connection on that port, it looks at the settings and it goes like, hey, I'm going to accept insecure connections as well as secure connections. So depending on the type of connection you make, Cassandra will handle it seamlessly. So this is one of those usability things in Cassandra 4.0 that are coming in. So it also makes it very easy for you to transition from a cluster that is running TLS between non-TLS connections to TLS connections for internode communication. All right, so on to 14.358. Partitioned outbound internode TCP connections can occur when node restarts. So this is one of those tickets that I was personally debugging, and it's a great example of how the community debugs issues. So here's what it actually means. What 14.358 does for you is internode TCP connections that do not act segments for 30 seconds will now be automatically detected and closed via the Linux TCP user timeout socket option. So what does this actually mean? So our contributors, Joey Lynch from Netflix, came reporting that there is an issue where they're seeing half-open TCP connections on Cassandra. And as a result of those half-open TCP connections, they were having issues with Cassandra not being able to detect and close those connections fast enough. There's a whole debugging story in that ticket. And this happens a lot with stateful firewalls, which tend to just sit in the middle and they just close the connection on one end, and the other connection doesn't really get closed, or the application doesn't detect it. So essentially, what happened is we looked at the issue, and then Joey came up and said, "Hey, there is this new setting in the Linux kernel." Or rather flag that allows us to set the timeout for unacknowledged segments. So when TCP is transmitting its packets, it's doing it it's framing it. And when certain segments don't get acknowledged, you end up sitting there waiting for a packet to come back. And there's exponential backup that the kernel does. And so you might be waiting for a very long time for the application to actually detect that the setting is, the segment is not going to come back. And so with this setting now, Cassandra can be tuned to wait only 30 seconds. Again, this is actually a setting that is Linux specific. So if you're running Cassandra on any other platform like Windows or any other platform, this won't work for you. So you've been warned. Most of us don't run Cassandra on any other platform except Linux, but just for those few folks who run it on Windows or other platforms, this might be an issue. All right, so on to Cassandra 15.623. This is a simple one, but it's an important one as well. CQLSH now returns a non-zero error code, or non-zero code in case of errors. So this is one of those things that there's not a whole lot of debate on. because this is a convention that is generally adopted by any program that runs on a shell. So if you run a shell command, that command typically returns a zero or non-zero error code. If that command fails, it returns a non-zero error code. If it succeeds, it returns a zero error code. This allows the script author to check whether the shell command that they ran was successful. So this is an implicit convention. And most of the Linux or Unix utilities, they follow this. But unfortunately, um, SQLSH didn't do that before 4.0. So what happened is, or rather what behavior you see is that when you run any SQLSH script in basically script mode, um, which is doing some it's changing, adding some data or running some SQL commands against a Cassandra cluster, it will always exit with a return code of zero. And return code of zero implies that everything was fine. And it would do that regardless of whether there were actual syntactical errors or there were any errors on the, I think even when it tried to talk to the server, and if there are no errors, it would just return a zero. Or rather, even if there were errors, it would return a zero. And so this is one of those annoying issues when you're when you're scripting something, you implicitly expect that the tool works like other utilities. So one of the classes of failure introduced is silent failures. And silent failures are very hard to figure out and debug. And hopefully with this change now, you wouldn't see those kind of silent failures in Cassandra, or rather with SQLSH. This did cause a lot of failures on our test suite because it actually, the test suite relied on the fact that SQLSH never returns a non-zero error code. Um, and we actually had to go and fix a bunch of test failures. It also exposed some of the tests that were silently failing, but we didn't know that they were failing. It actually exposed a couple, minor issues, not with SQLSH, but with the way the test was written. All right, so 14902. This actually is bumping up compaction throughput per second to 64. And this is again defaults. You want to be aware of this. What is the setting? It basically controls the throughput of the compaction. So depending on the right throughput that you get on a Cassandra cluster, you might add a lot of SS tables. And these SS tables are periodically compacted together to form larger SS tables. Now, what happens is when you fall behind with compaction and a lot of SS tables pile up, Cassandra has to do bookkeeping per SS table. There are various components of each SS table, and all those components are loaded up in the metadata and bookkeeping overhead of all those components is pretty high. So you want to keep the number of SS tables to a specific number. And so compaction kicks in periodically when it and when it kicks in for a few moments or quick period of time, compaction is going to increase the number of SS tables as it's compacting all those SS tables down, and then it overall reduces the total number of SS tables. So the setting that we had was from the era where we had Cassandra running on spinning disks. And so this is one of those settings that people had to tune out of the box. The moment you install Cassandra, the first thing you do is go and this, because now you're running it on SSDs. So this will help with folks running Cassandra with sensible defaults when it starts up. All right, 14.388. So this is another change related to compaction. It is kind of a feature slash it is exposing certain settings to the operator. Basically, LCS, which is the level compaction strategy, it respects the max threshold parameter when compacting. So earlier, this max threshold parameter only applied to SDCs, as I understand. And it was internally in Cassandra's code base, this threshold parameter for LCS was hard coded to 32. And what's the problem with it being hard coded to 32 for LCS is when somebody changed this max threshold parameter and you're not super familiar with how Cassandra's compaction strategies work, you might actually end up believing that that threshold is going to affect all the compaction strategies. But it doesn't work that way with LCS. And the other thing is, depending on the size of the SS tables, this threshold parameter of 32 that's hard-coded may be too big or too small, depending on the data set that you're storing in Cassandra. And so what ends up happening is you may run out of memory when you're trying to compact with LCS, and the threshold is too large. And so you want to constrain it to a smaller value, or if it is too slow, and you have more memory, you want to increase that. So this tunability didn't exist. So this also applies to both now SDCs and LCS equally. And with SDCs, it specifically applies to the L0 compactions. With LCS, it applies to L0 to L1 compactions. All right, this is another interesting thing. It's a ticket that I also worked on, which is flushing with fast compressors by default. So this is another of those issues that you would only get to experience with Cassandra under load. So with Cassandra 4.0, we introduced Z standard compression. So now Z standard compressor is able to compress all types of components within Cassandra, starting from the SS table to the commit log to anything that the compressor can compress, basically any of the components that are compressible. So so what happens is that Z standard and other compressors are generally quite slow, and they block flushes. So what happened is when you change the compression strategy from LZ4, which is the fastest compressor, to anything that is not LZ4, including LZ4 with high compression characteristics, right? The compression is too slow. And so when you have a lot of data arriving in Cassandra, the data goes into the mem table, and then the mem table gets flushed to disk. And when it is flushing, the thread that is flushing to the disk, let's say it's using Z standard. Z standard has a lot of tunables, and the highest tunable value, which is the maximum compression value, is something like 22, I think. And at 22, the rate at which it compresses is very, very slow, but the compression ratio is very high. So you get a lot of space saving at the cost of CPU. But what happens is if you have a lot of data that's arriving to the node, you're building up a backlog of a bunch of mem tables that need to be flushed. And this flush thread is busy compressing this data using the Z standard compression. And so it blocks and causes the process to become very unstable. So what does 15379 do is it decouples the flush compression setting from the compression parameters. So when you create a table in a key space, you have these compression params that you can pass in, and you can say create table with some compression parameters. So these compression parameters include the type of compressor you want to use. It includes the compression threshold or the compression ratio or whatever settings that each compressor takes. And what happens is we take that into account only when we are compacting, not when we are flushing. So when we are flushing, we're still flushing with the fastest compressor available. It will automatically detect that you are using Z standard with a high compression set. Uh, so it'll pick the fastest compressor it can find for flushing. Then when it defaults to LZ, the fastest compressor, and then it relies on compaction to recompress your data. So what you will see is that initially the SS table will be uh, flushed to disk using LZ4, but eventually when it gets compacted, it's going to get recompressed using the target compressor that you have specified. So you would see, like, initially that the data size is higher, but then once compaction kicks in, you'll see that reduces a significantly low number. And when Netflix has tested this in some of the schemas and some of the clusters, they actually got about 50% space savings. That's also ticket. But I'm guessing that they were not using any sort of compression before, and with Z-Stand they got um, a lot of space savings. All right, so on to 14.197. There's an option now to automatically upgrade SS tables after Cassandra upgrade. So this is one of those nice to have features as well. Like you start up Cassandra and it just upgrades the SS tables automatically. So you can specify this setting in the Cassandra YAML, or trigger it via JMX. And it will automatically take care of upgrading your SS tables. You don't have to specifically run upgrade SS tables. It'll do it in the background, I believe. All right, this is one of the older tickets in Cassandra that's been around for a while. And this is an experimental option to compare multiple Merkle trees together at the same time. And those of you who don't know what Merkle trees are, this is a data structure that Cassandra uses repair time, I believe, to compare data sets between two nodes without actually having to transfer the entire data set. So it's a representation of a compact representation of data that exists on a node. So if two nodes send you a Merkle tree, you can actually check the Merkle tree on each of the nodes and compare what rows or what partitions are different, and then only stream those specific partitions. So in case you have very small data differences between two nodes, you can reconcile those differences very quickly by just transferring the Merkle trees and checking which of those rows are different. So in a typical scenario, you have two nodes, one in sync, two nodes in sync, and one is out of sync. This is the most common scenario that Cassandra has, where one of the nodes went down or became unreachable, and at that point, it went out of sync. And it went out of sync for a few minutes or a few seconds. You don't have a whole lot of change between the nodes, right? So, so originally, before 4.0, the Merkle trees were being compared pairwise. So what that meant was, if you had three nodes, each node would get two Merkle trees from nodes, its peer nodes, the replicas, and then it would send its Merkle tree again back to other nodes, because each node needed to compare with the other two nodes. And now with this change, instead of doing a pairwise compare, now you can compare all the three Merkle trees together, reducing the need for comparing individual pairwise. So overall, it lowers the data that is transferred. I mean, Merkle trees are inexpensive as such, but for data set that is fairly large, they can grow big, and so any reduction in data transferred means you have lower time, lower the time that it takes to compare is lower, and also the speed with which you can reconcile the data differences is higher. So overall, it makes the system far more efficient than it is before. So This affects situations where you have RF3 by, I think, reducing the overall uh, data requirement by 25%. But in RF5 or higher RFs, you will see much more reduction in the data that's transferred. So that's 3200. On to Cassandra 13.130. Interesting, and this is one of those user-facing features that are coming in 4.0, is there are new functions to get time in SQL. So what's the canonical way of doing this? You just select now. Now was the function that you had, and then you had to do some manipulation to it. Now you actually have current timestamp, current date, current time, and current time UUID. All these four functions are available in SQL to actually get the current date and time and timestamp ID from Cassandra. So you don't need to do any of the manipulation before. All right, so here are two tickets. They are one after the other, 11.935 and 9.36. There is support for arithmetic operations between timestamp and date and duration. So earlier, you couldn't perform these arithmetic operations, and now that support has been added, and including support for arithmetic operations on numbers, which is again one of the convenience features for application developers, that you can actually do this in your queries on Cassandra. So actually having to do this in the application. So this is one of those useful features for application developers. Again, a convenience feature. It's cheap and it's not very expensive in general. All right, so preview repair streaming that comes in through Cassandra 13.257. So this is not really a big feature or anything that most people will need, but sometimes you need a way of debugging what repair is doing. And as part of repair, we actually stream data between nodes, right? And there are scenarios in which you would like to what repair streaming would look like before actually initiating that. So this allows us to preview expected streaming required for a repair operation. So it's very simple. You just use node tool repair / preview, and it actually just does a dry run and shows you the data transfer that's going to happen as part of that repair operation without actually doing the data transfer. And this is again geared for making it easier to debug what's going on with Cassandra rather than actually having to initiate the repair before it does. Right. So this is another useful feature for operators than developers. Cassandra 13.848. This is another feature / a minor improvement, but it actually makes it much easier to do certain tasks. So SS-table dump is a utility that basically allows you to dump an SS table as a JSON object. And the default behavior is to dump this entire SS table as a single JSON object. Now, this is possible, it's possible to do this dump using, or rather, on small SS tables. For SS tables that are very large, this really is not really a good option because the way JSON parsing works is that you have to parse the entire document. And if you dump the JSON document into a file, it's going to be way bigger than the SS table. And so there is a new option, -L, that's been added to this tool so that each partition is outputted as a JSON doc or a JSON object in itself. Actually read the file one JSON object at a time rather than reading the entire file into memory. And in some cases, you can't even do that if it's a very big file. So this allows you to basically chunk the output individual lines. So you can take one JSON object per line and read it into memory. So there's another convenience feature for those of you who didn't know is coming in 4.0. 14.232. This is an interesting feature slash observability thing that's improving in Cassandra 4. It introduces the write latency metric. So it exposes this latency metric to the operator. So you can actually see what the write is at the coordinator layer, and it is per table. So you can now track latencies per table and coordinator tier. Here you had write latencies, but it was not at the coordinator layer. And this is important when it comes to tracking latencies across the cluster and detecting where the hotspots are. Yes, I agree with Patrick that a lot of these, again, are understated improvements. But when you're debugging Cassandra, it is these could be very, very important changes. 13.985. This is another of those changes that operators can now actually use to restrict data centers. So what does this actually do? So quickly, Cassandra is deployed in two DCs. One is the OLTP and the other one is the OLAP data center. And basically, it allows you to split this access across the two different data centers so that a user doesn't accidentally run analytics queries on a OLTP cluster or OLTP data center. So that's a new feature. So you can basically restrict access to this data center for each user. And Cassandra 10.190, I think we are almost out of time. So I'll just run through these last few slides. 10.190 is adding Python 3 support. So don't worry, we are not taking away the Python 2.7 support in SQL, SH, but Python 3 support is getting added in addition to Python 2 support. But Python 2 is getting deprecated, end of life, killed at the end of this year. So so it's best that you try it with Python 3. 14.825, this is kind of a big change where there is server-side describes now. So the nice thing about it is that the drivers now don't need to individually implement describe statements in the driver code base. So you are kind of guaranteed that the describe that you're going to get the describe output from the server, which should be consistent across all drivers. Fred's comment is that Python 2 was EOL'd end of last year. Yes, so it was technically EOL'd, but I think they want to just remove all the packages in 2021. So that you're going to see build failures and stuff like that happening in 2021. That's my understanding, but yeah, I could be wrong. So anyway, describe support is getting added to Cassandra 4.0 server-side describe. All right, so in summary, 4.0 has a lot of features. The mainstream features are great, but these are some of the hidden goodies that are coming with 4.0. And I would love you all to try it now and give us feedback. The is available on cassandra.apache.org/downloads or download. Please give it a try and file JIRAs if you find issues with it. We are trying to really, really hard to make this a stable release, and the more people who test feedback we get, and we can move faster in making this into a GA release. All right, so finally, we are hiring. If you are interested in working at Apple, please follow this link. I'll leave it up for a couple minutes. And if you're interested, just fill out a job application, and hopefully somebody will get back to you. Thank you. I'm open for questions if anybody has questions, but I think we are over time. So you can ping me in Slack if you have questions or you want to discuss anything. I'm available on Apache Slack. Also, if you have a question, please put it in the chat so that I can answer it. All right. Okay. Thank you, Paulo. It was great, great presenting. Hopefully, this gives everybody a good overview of what is coming with 4.0 and stuff that is a bit understated as well. Thank you all, and see you around. I'll be in ASF Slack if anybody wants to chat.